Hello everybody. So this is going to be our first video on graphing linear inequalities. So this is not in the note packet, but you can go to page 15, which has the four graphs on that page, and then you can write this down below. So these are the things that you want to watch out for, so little nitpicky details that we got to be worried about. So whether or not we're going to be including the points on our line or excluding the points on our line. So these are the things that are needed if you're going to be including your points. You'll see a less than or equal to or greater than or equal to sign in there, and that should be signified by a solid line. If you were doing like domain and range, then that's what kind of this stuff is. This stuff all correlates to like domain and range, which we will come back to eventually, but not right now. So we're kind of just focused on this stuff up here. So when you are graphing these things, if you see the equal sign, you're going to be doing a solid line. If you don't see the equal sign, it's going to be a dashed line. And then what we have to do is we have to also shade these lines. So if you see something like y is less than, or y is less than or equal to, or y is less than, you're going to be graphing and shading below that line. And if you see y is greater than or equal to, or y is greater than, then you're going to be shading above that line. So the shaded region represents all of the solutions for that inequality. So that means any point you pick in that shaded region is going to represent a true statement when you plug it back into the inequality. And that's what we're looking for, is we're looking for all of the solutions that work. What are all the different values for x that when I plug them in, it will come up with a true statement when I also plug in its matching y value. They're all going to be either bigger than or less than whatever that y value is. So let's go through an example and talk it out. So first thing to note is that when we're looking at graphing these inequalities, this one is in the unit packet on page 15. These are in y equals mx plus b form. So they look like this form, but instead of an equal sign, they have an inequality. So when I see this right here, less than or equal to, that tells me two things. That tells me, one, that we're going to be graphing a solid line, and that also tells me that if it's less than, it's going to be below whatever the line is that I graph. So we kind of think about this as if it was y equals mx plus b form, and we want to identify our m, and we want to identify our b. Now that b is, again, where we begin, and here we're going to begin at 0, 4, 1, 2, 3, 4. And then the slope is the number in front of the x. And again, if there is no number written, it's assumed to be a 1. Since there's a negative sign, it's like -1. And for slope, we like to think about it as rise over run. So we can turn it into a fraction by putting it over 1 if it isn't our fraction already. So that means from this one point, we're going to go down 1, over 1, down 1, over 1, down 1, over 1. Or the opposite way, up 1, left 1, up 1, left 1. So now because I see that equal sign, this is going to be a solid line. Whoa, what is that thing? Ignore that. Where is line? Here we go. There we go. Just trying to line it up a little bit. And why doesn't it have the two endpoints? All right, so it's going to look like that, something like that. And we are solid line here because we have the equal sign, and then we want all the values of y that are less than this line. So here's my line. I want all the values that are less than or equal to it. So I'm going to come over to my highlighting device, and less than that line is going to be everything in here. So if you would pick any single point that's in here, it's going to give you a true statement that's in that. If you wanted to check that, you just pick a point. So like the origin is always an excellent point to test. So if you wanted to test the origin point out, you would go something like this. So here the point that I'm testing is 0, 0, and again remember that this is your x and that's your y. So if I take this inequality right here, and I replace the y with 0, and I replace the x with 0, the question is, do I get something that is true? So is 0 less than or equal to, well, -0 is 0. 0 plus 4 is 4. Is 0 less than 4? Certainly. So that means this point and every other point that's in here in this region represents a true statement for that inequality. You're always going to end up with something that's true. Some number is less than some other number. And then it's also true for anything that's on that point because of that equal sign. That equal sign is what makes it so that anything on the line will also work. Great. And that's pretty much all you got to do. And then sometimes students forget, like if it's dashed, you don't do it, you draw it solid. So I'm okay if you want to write on here that like, hey, this should be a solid line. So so that's that one. Moving on to the next one. So here we got y is greater than 1/3 x plus 1. Oh, and I copied this back. So you can copy this every time you're doing these problems in the future. So question, where do we begin? We begin at the 1. This is my b. And this is correlating to the y-intercept at 0, 1. And then my slope is how I'm moving. Here my slope is 1/3. So that means I'm going to go up 1/3, up 1/3, or down 1, left 3. Now, again, so since this thing does not have an equal sign, that means that this is going to be a dashed line. And since it's greater than, that means it's going to be shaded above that line. So that's what that symbol tells me. It tells me those two things. So now I gotta find, can I make that blue? Let's see here, sure. All right, pretend that's straight. And if you want to go back, you can say that this line should be dashed, in case you forget to make it dash when you're doing it. Otherwise, you can send your eraser through and erase a few of those spots, but try to make it obvious. And this is the way to make it obvious, is just to tell me, write it out, that this should be dashed. And then where we are shading is y is greater than that line, so we are shading everything above that line. If you wanted to do a test point for this one, you can't pick, well, I mean, if you pick 0, 0, you should get something that's false, but we want to get something that's true. So I don't know, pick something, this looks like a good point to test. What is that? That is the point 0, 1, 2, 3, 4, 5, 6. That's a 2, 4. Oh my God, 6, 8. Okay, I don't know. My eyes can't see straight. That looks like about 0, 9. So if I were to replace the x with 0 and the y with 9 in this equation, I'm going to get 9 is greater than 1/3 times 0 plus 1. 1/3 times 0 is 0. 0 plus 1 is 1. Is 9 greater than 1? Certainly it is. So you pick a point that works, and that means everybody else on this point, on this side of the line, will work as well. So there's an infinite amount of points that work, and that's that, dashed, shaded above. So what you guys can do now is try these ones out on your own, see if you can make it. When you get done, you can watch the next video, which will have the solution guide. Thank you.